Okay, Oak Rovers, this is going to be a video to help you solve a special kind of quadratic called the difference of squares. Now, the reason why they call it difference of squares is because I'm taking two perfect squares. In the top case, it's going to be x squared and 64, and I'm going to subtract them. Difference in mathematics means subtraction. So if I have a difference of squares, I'm going to be subtracting two perfect squares. Now, first of all, I'm going to show you how I can use my generic rectangle and diamond problem to solve these problems, and they'll work for any difference of squares. But then I'm going to show you a shortcut if you notice that it's a difference of squares that you can use. So when I'm factoring a difference of squares, I always put my big tiles or my x squared tiles in the bottom left, and then I'll put my unit tiles in the upper right, just like before. Now these two rectangles or boxes have to add up to 0 because there's no x term or middle term. So they have to have a sum of 0, but they still have to have the same product. These two rectangles have to have the same product as the other two rectangles because of Casey's rule. Well, these two rectangles have a product of negative 64x squared. So I'm going to put negative 64x squared up here in my product of my diamond problem. Now they have to have a sum of 0, so they have to be opposites of each other, and they have to have a product of negative 64x squared, so one's positive and one's negative. Well, that would make sense. So the two numbers I'm going to put into those boxes are 8x and negative 8x. After I put them there, I'll put them over here back in my generic rectangle. Now I have an 8x and an x squared, so I have a factor of x in that row. If this dimension's x, and my area is x squared, this dimension also has to be x. If this is x and my area is negative 8x, that's going to be negative 8. If this dimension's 8, if this dimension's x and my area is 8x, then that dimension also has to be 8. So to write this quadratic, which is x squared minus 64, which is another word for a difference of squares, as a product, I'm going to write it as x squared minus 64 is equal to x plus 8 times x minus 8. Now I want you to notice that x plus 8 and x minus 8 are really the same form as my problem that I have down here, where I have a squared minus b squared is equal to a plus b times a minus b. Now a is just the number or what I square first, and b is what I square second. In the case up here, x squared, I'm just taking x and I'm squaring it. In 64, I'm taking 8 and squaring it. So I'm left with x plus 8 times x minus 8. Let's try another one that's a little bit more complicated. Just like before, I'm going to put my big tiles or my x squared tiles in the bottom left and my unit tiles up in the upper right. Now the product of 25 times 9x squared is negative 225x squared, but the sum of these two boxes has to be 0 because I don't have an x term. So my product of these two boxes has to be same as this product, which is negative 225, and my sum is 0. And I put both of those into my diamond problem. Now 225 is a perfect square. It's going to be 15 squared. So I'm going to have positive and negative 15x. So I'll put both of those into my boxes. In this row I can factor out a 3x. If this dimension's 3x, this dimension has to be 3x to get a product of 9x squared. If this dimension is 3x and my area is negative 15x, that has to be negative 5. And if this dimension is 3x and my area is 15x, this has to be positive 5. So to write this as a product and sum, this is my sum, it's going to be 9x squared minus 25, and that's equal to 3x minus 5 times 3x plus 5. Now if I look at this carefully and compare it to my one above here, a squared minus b squared, what's the square root of 9? Well, that's 3, and the square root of x, let me say that again. What's the square root of 9? That's 3. What's the square root of x squared? That's x. So the square root of 9x squared is just going to be 3x. And that's my first term in both of these as I write it as a product. The square root of 25 is just going to be 5. So I have 5 in both places. So if I look at this, this is really 3x minus 5 times 3x plus 5, where 3x is my A and 5 is my B.